If I start with 25 grams of lead-2 nitrate and 15.0 grams of sodium iodide, how many grams of sodium nitrate can be formed? Well, okay, this is a limiting reaction kind of problem, so I'm going to be running two stoichiometry problems at the same time. The thing is, what we know over here is we know that we're going to start with 25.0 grams of lead, Pb2 nitrate, NO3. Eventually, we want to figure out how many grams of sodium nitrate we are able to form, NaNO3. All right, so there are some things that I can add to my conversion factors. Like, for example, how many 1 mole of PbNO3 is how many grams of PbNO3? 331.21. So now I can go 331.21 grams of PbNO3 for every 1 mole of PbNO3. Now I can look here in order to build a mole ratio. For every 1 mole of PbNO3, I get 2 moles of NaNO3. And so let's see, I want 1 mole of PbNO3 to be in the denominator, and I want 2 moles of NaNO3 to be in the numerator. Now, let's tidy up a little bit. I can cancel grams of lead nitrate. And now I can cancel moles of lead nitrate with moles of lead nitrate, leaving me with moles of sodium nitrate. And I'm going to need 1 more box in order to complete this, because now I need to go and figure out 1 mole of sodium nitrate is how many grams. And that is 85.00 grams of sodium nitrate. So I can do 1 mole of sodium nitrate gives me 85.00 grams of sodium nitrate. And once again, I can cancel moles with moles of sodium nitrate, leaving me in grams, which is what I want. All right, so when I do this mathematics, I'm going to bring it around here. I'm going to type the numbers 25.0 times 1 times 2 times 85.00. I'm going to divide that by 331.21 times 1 times 1. So when I do the math on the top, I get 4250. When I do the math on the bottom, I get 331.21. When I simplify that math even further, I get 12.83174 grams of sodium nitrate. Okay, and then if I were to sig fig it, 3 sig figs. I think that, yep, I would have 3 sig figs. So let's see, that 12 would be 1 and the 2 is significant. The 8 is significant, the 3 is not, but it's important. In this case, it does not round up the 8, so I have 12.8 grams of sodium nitrate. But that's not the end of it. I also have 15.0 grams of sodium iodate. So, 1 mole of sodium iodate has a mass of 149.89 grams of sodium iodate. And so I'm going to put 149.89 grams of sodium iodate in the denominator so that I can cancel, and 1 mole of sodium iodate. And I do that so that grams cancels with grams, leaving me with moles. Alright, if I take a look at the balanced chemical equation, I see that for every 2 moles of sodium iodate, 2 moles of sodium nitrate. So I'm going to put 2 moles sodium iodate over 2 moles of sodium nitrate. I do this so that the moles cancels with the moles, leaving me in the moles sodium nitrate. 1 mole of sodium nitrate has a mass of 85.00 grams of sodium nitrate. So I can put 1 mole and I can put 85.00 grams of sodium nitrate. Moles cancels with moles, leaving me in grams, which is what I want. So when I do the math, I will start with 15.0 times 1 times 2 times 85.00. All of that will be divided by 149.89 times 2 times 1. So when I solve the top, I get 2550. When I solve the bottom, I get 299.78. When I simplify that a little bit further, I get 8.506, 2 grams of sodium nitrate. Okay. And once again, three significant figures, so 3 sig figs. So the 8 is significant, the 5 is significant, the 0 is significant, the 6 is not significant, but it is important because that 6 is going to round that 0 up to 1 grams NaOH.